welcome to Shri Sathya Loka Seva Gurukulam online classes. We've been learning about limits and continuity. In the previous classes, we've learned what are limits, how to evaluate them, how to use special formulae and standard limits to apply them in questions to find what limiting value the function takes you to. In today's class, we are going to learn about continuity of a function at a point. So basic concept, looking at it looks a little complicated, but it is, trust me, it's not that complicated at all. What is continuity? Something that is continuous. When you draw a curve without lifting your pen, then it is continuous. If I lift my pen, then it is not continuous. It's as simple as it is. Now we just need to see continuity of a function at a point. So you just need, let's suppose this is the point that we are looking into. We just need to see whether it is continuous before and after this particular point. You're able to draw the curve without lifting the pen, starting from before that particular point and moving till some distance after that particular point. That is it. Okay, let's see a few examples. Let's consider this particular function. What are basically functions? They are relations between two variables. When we plot them in a graph, we get some curve, straight line or some sort of figure on the graph, right? So let's suppose this is one graph that we have to deal with. So let's see that and understand whether it is continuous. It's very, very obvious when you look at it only that it is not continuous. There is a part of the graph here and the part of the graph here. So around this point, of course, it is not continuous. But this part is and this part is. So we have to see where we are looking into the continuity. If we are looking at continuity at A, then of course it is not continuous because before A, it's here. And then after A, I need to lift my pen up and then move ahead. Moving on to the next example. Now, if you look at A, there is a gap. The graph does not exist there. There is a hole. So there is a break. Again, this curve is not continuous. Let's look at the third example. If you see here, there is a gap and there is a break here. So again, I can see that exactly at A, the function is definitely not continuous. And I cannot draw it at one go. Now look at the last example. If you look into the last example, it is continuous at A. You're able to draw the graph such that it extends before and after that particular point. Now as a layman, I'm able to see that it is continuous. But how do I prove it mathematically? So there are three conditions that I'm looking in for. So when I move from left, meaning when I find the left hand limit of a function, if that leads to a value A, my right hand limit should also lead to the value, same value A. So in short, it means that my limit exists at A. That is limit x tending to A, f of x exists. That is one criteria. Not only that. If you see here, from the left and from the right, it leads you to the same point. But if you observe very keenly, f of A, function at A does not exist. At A, this is your f of x value, right? Your y value is your f of x value. Now, at that point, there is a gap. It doesn't exist. So, it's again not continuous. So, the limit at the function should exist at that point. That is my next criteria. Meaning, f of x should exist at A. Meaning, f of A should be a valid number and that should be equal to my limit of the function at A. If not, it will be like this. The left hand and the right hand limit exists, but unfortunately, the function value is not the same. So then again, it is not continuous. So so my basic criteria for continuity is that I will check whether limit x tending to a f of x exists, and that is equal to my function value at a. So limit x tending to a, f of x is equal to f of a. This is what I am looking at. If this criteria is satisfied, my function f of x is continuous at a. Hope you understood the concept. Let's quickly move on to the questions. Let's solve few questions and see. Here, f of x is equal to x minus 5. This is my function. I need to check whether it is continuous at x is equal to 2. So now how do I do that? Now let me first find limit x tending to 2, f of x value. So how do I do that? Limit x tending to 2, f of x is going to be 2 minus 5, that is equal to minus 3. So let's number this as 1 first equation and keep it. Now let's find what is f of 2 value. What is f of 2? F of 2 is again 2 minus 5, that is equal to minus 3. This is my second result. From 1 and 2, it is clear. It implies that limit x tending to 2, f of x is equal to f of a. Therefore, function is continuous. So here, if you see in this example, we are substituting 2 in place of x in both the places. It will seem to be a little confusing now, but you will see in few other examples that we will be discussing how both are different. So let's move on to the next question. If you see here, the function is defined in 2 different ways. One below and equal to 1, the function is x square. And then greater than 1, the function is x plus 5. So we'll see how to find whether this function is continuous. Now, at 1, exactly at 1. So you need to draw it without lifting your pen before and after 1. Okay. So now let's first find limit x tending to a, f of a. Limit x tending to a, f of x, sorry. So now how do I find this? Now limit x tending to a, by a is 1. So limit x tending to 1, f of x I need to find. Okay. So now to find this limit, let's first look into the left hand and the right hand limit so that we will be able to arrive at the limiting value. Now what is the left hand limit? Left hand limit is going to be limit x tending to 1 minus f of x. That is limit h tending to 0, f of 1 minus h. Okay. So now limit h tending to 0. What is f of 1 minus h? We are approaching 1 from a number that is less than 1. So less than 1, we have this x square, right? The function is x square. So I will substitute 1 minus h the whole square here because I am finding f of 1 minus h. So now when I substitute the limit, I am getting an answer as 1. Now look into the right hand limit. Right hand limit is going to be limit x tending to 1 plus f of x. We are approaching f of x from a number greater than 1. So this is my function. So this is going to be limit h tending to 0, f of x, that is f of 1 plus h. So now that's going to be limit h tending to 0, 1 plus h plus 5. That is 6 plus h. When I substitute 0 here, I am getting 6. My left hand limit is not equal to the right hand limit. So I can see very much that this function is not continuous at x is equal to 1 because the limit itself does not exist. So only if the limit exists and that is equal to the function value, then we can say that this function is continuous. So basically when we check the continuity, we need to first check if the limit exists and if that limiting value is equal to the function value at that particular point, then we can decide that it is continuous. But here the first criteria of the limit itself is not existing because the left hand limit is 1 wherein the right hand limit is 6. So here the limit does not exist, which implies the function is not continuous. Let's move on to the next question. The next question says that find the value of the constant in the function given below. So there is a function that's given and we are asked to find the value of the constant. As I told you, A, B, C are used to denote arbitrary constants, meaning they are constants otherwise in that particular situation, but they are unknown as of now. So we denote them with A, B and C, A, B, C, etc. So here if you see, he says find the value of the constant in the function. So we are supposed to find the value of B. And it's given that f of minus 2 is equal to 2 by 3. So we know that f of minus 2 is 2 by 3. Correct? So we'll substitute in this equation. So we know f of minus 2 is nothing but 2 into minus 2. So f of x is this. So instead of x, when I have minus 2, I'll replace minus 2 here too. So minus 2 plus 3b and the value is given as 2 by 3. So I have minus 4 plus 3b is equal to 2 by 3. And it also says that f of x is continuous at x is equal to minus 2. Meaning limit x tending to minus 2, f of x is equal to f of a. So I can clearly say that f of minus 2 is this. So from here I can find the unknown. 3b is equal to 2 by 3 plus 4. So I have 3b is equal to 2 plus 12, that is 14 by 3, and this clearly implies that b is equal to 14 by 9. So my function here becomes f of x is equal to 2x plus 3 into 14 by 9. That's nothing but 2x plus 14 by 3. So this is my f of x. And it is continuous at x is equal to minus 2. So my b value is nothing but 14 by 9. Hope you've understood this question. So today's class, we've dealt with three types of questions. The first question was that we tried to understand whether a simple function is continuous at a given value. So what is the rule of continuity? Limit x tending to a, f of x is equal to f of a, then this function f of x is said to be continuous at a. So the limit has to exist and that should be the function value at that particular point. Secondly, when functions are redefined like this in different ways, in different places, different interval of numbers, then how do we check the continuity? So that we saw, and here we saw that the limits itself did not exist. So we decided that the function is not continuous. Thirdly, we had to find the value of the constant. Given that f of minus 2 is equal to 2 by 3, such that f of x is continuous at x is equal to minus 2. So we know that f of minus 2 is equal to limit x tending to minus 2 f of x. So we use this property to find the value of b. So with that, this class is done. Thank you.